we come back to the editor and we implement. Actually, we create a new folder. We create a new folder called Pathfinder, and actually you can create a script called Pathfinder and start to implement it. First thing first, we need to pass here, just for a visualizing purpose, a serialized field private material. Just be sure to use serialized field and not public fields here, just because Unity suggests that. So just use serialized field, not public material. And we're gonna set the start material. We're gonna create this in a second, these materials in a second. These are only for visualizing purposes, as I just said. So serialized field, private material, and node, and serialized field, private material, explored cell, serialized field, private material, in core cell, serialized field, private material, path material. So now we need to specify which are our neighbors. So the neighbor of a single grid cell. So I want to make an 8 neighbor policy. So we want to have neighbors. So if we choose to be here, I want my neighbors to be this, 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 and this. So 8 neighbors, all my diagonals and all my up, down, left, right directions. So in order to do that, I'm creating an array of vector2 ints that specify our direction. So vector2 of int, an array. We're going to create it as a static array just to optimize a bit the code. Neighbors. Okay, so we have all our neighbors, all our diagonals, and our up, down, right, and left directions. These, as you can see, is simply an array of directions. And now we're going to say private list of node queue. I'm sorry. This should be a capital N, and we're going to implement a queue. So as we did say in the previous video, we need a BFS to implement Dijkstra, just to explore the matrix. So we're going to create a queue data structure with a list, really simple and straightforward. So now we're going to create our public void Dijkstra algorithm. We're going to accept some parameters. Actually, we do need our list of node called nodes. That is actually our ground matrix. Our vector2 int start position, vector2 int destination position. Okay, so we have everything and we can start to implement the algorithm. We're going to initialize the queue inside the algorithm. So every single time that we run it, we can recreate the queue from scratch, and we'll create a new list of node. Now we say that our starting node should actually be nodes of start position.x and start position.y, and then we say starting node, as we call it, distance is equals to 0, because our starting node should be 0. Actually, if you want to check the implementation, you can even check the Wikipedia page that tells you how to start the algorithm and how to implement it. Actually, this is more a practical lesson on how to implement it in Unity. So actually, the first distance should be 0. We say starting node.cell .get component. We need our component mesh renderer. So mesh renderer dot material is equal to start material. And now we need to set the destination position material, and I will do it really quick. Actually, no, let me do it as I did for the starting node. So destination node, and now we're going to say destination node dot cell dot. We're not setting the distance because we don't actually know the distance of the destination node. Actually, you can make like the checks for the starting node and for the destination node to be sure that the input that you receive, these positions are valid positions. I'm not going to do it because I think it would take time. It would make the code dirtier, and you can do it if you want to deploy your own app, but I'm basically teaching you how to implement the algorithm, not the whole UI part. So all the all the user experience part. So we're gonna set the mesh renderer, as we said, the material to be as we did for the previous one. So material equals to the end node. Okay, and now we're gonna before that we're gonna add our start node, and then we're gonna create so we want to create a coroutine that in Unity will allow us to create animations real time, as you saw in the previous video. Actually, you can create the animation of the explored node, the matrix that is being explored at every step, and also the animation for tracking the path. So we're going to create a coroutine that is basically a routine that runs in parallel to the main loop of Unity. If you want to know more about this method, this standard method of Unity, just please be sure to read the description. I will link the documentation to you. So we're gonna call explore ground, let's call it explore matrix actually, and we need to explore the matrix. We need the nodes. Then we need the source position and the destination position. Sorry, I called it start position.